a lot of you were on the right track or heading in the right direction, but very few of you got full credit for the problem. So the problem is this. And, okay, so first of all, let's divide by 2. So we have the sine of some angle equaling root 3 over 2. Well, that's a positive number. So where could this angle be if its sine is a positive number? Ignore this, the sine of an angle is root 3 over 2. So where can it be? 1 or 2. Sine is y, and y is positive up here. Now, what kind of an angle has a sine of root 3 over 2? 60, or in radians, pi over 3. So, right now, whatever that angle is, and he happens to be called 2x, that angle is either pi over 3 or this angle, which would be 2 pi over 3. It's pi minus a third. This one is pi minus a third. This one would be pi plus a third. But because the angle happens to be named 2x and not x, I have to look not between this says between 0, x is between 0 and 2 pi. So 2x would have to be between 0 and 4 pi, which means that I have to go around again. So, what would this coterminal angle be? This angle that's coterminal with pi over 3, what would that one be? 7 pi over 3? Because it's 2 pi plus pi over 3. And then what would this red one be that is coterminal with 2 pi over 3? What would that be? 8 pi over 3. Now, these aren't the answers though, because those are the 2x values, and you have to find the x values. So the x values are just half of all these. So that would be pi over 6. This would be pi over 3. This would be 7 pi over 6. And this would be 4 pi over 3. So those are the actual final answers to the problem. Okay? Okay, wanted to take care of that for sure. Anything else on your quiz we need to look at? Yep, Charlie? Number 2 says the sine of Q is negative root 33 over 7. And Q is where? Where is Q if it's between pi and 3 pi over 2? Third quadrant. So Q is in quadrant 3. And the sine is negative root 33 over 7. So there's a picture of the given. And I want to find the cosine of Q over 2. Well, to find the cosine of Q over 2, I need my formula, which is 1 plus the cosine of Q over 2. So I got to look at this picture, which is a picture of Q, and figure out what the cosine is. Well, I need to figure out what the side is first. So doing the Pythagorean theorem, what does that side turn out to be? Negative 4. Some of you forgot your negative. That's good, we have to be careful, but it's negative because it's in quadrant 3. So then I can plug in, so I have 1, basically minus 4/7 over 2. Now, you do whatever you want. Some of you did very wacky, strange things. I like to just multiply everything by 7. So I get the square root of 3/14. Then I'll multiply top and bottom by 14. Under the radical, multiplying by the square root of 14. David, what are you doing?
Oh, hold on.
Yeah, you're bad. Did you ace this quiz?
No.
Okay. Add you to the growing list. Okay. Now, what do we have? Since I multiplied now by 14, my bottom is just going to be 14. And my top is going to be the square root of 42. Now I have to decide if I want the plus or the minus. So I come back to my given, which is right here. And it might be easier to do it in degrees if you want. Take half of everything, because your problem is Q over 2. So where is Q over 2? Q is in quadrant 3. Where will Q over 2 be? Quadrant 2. And the cosine in quadrant 2 is negative. So we need a negative root. Okay, Charlie? All right, everybody okay on 1, or do we need to look at 1 for someone? We're all okay on 1? Okay. All right, so now I turn back other stuff too, so we can really do anything you want. Let's get our review sheet out. And I have tried to, on the review sheet, give you 2 or 3 or 4 examples of each kind of problem. So, you kind of look at that both sides. There's a lot of problems on this review. Kind of look at both sides. And what do you think we need to practice? David? 3A. So on your test, you will have, you'll do, I'll give you 3 verifications and you'll do 2 of them. You'll get to pick which 2 you want. So, of course, there are lots of different ways to do the problem. But what occurs to me when I see this right here is that I have a formula for that, don't I? What's the formula for the tangent of an angle plus an angle? Oh, by the way, what's 3 pi over 4? $135. So if it's easier for you to do it in degrees, go ahead and do it in degrees. That's up to you. But the formula for the tangent of an angle plus an angle is tangent of the first plus tangent of the second over 1 minus tangent of first, tangent of second. So what do you think I'm going to do now? What? Someone said something. Exactly. Figure out what the tangent of 135 is and plug it in. So let's see, 135 is over here. What's the reference angle for 135? 45. So I have 1 root 2, and I'm not going to forget that negative right there. So what's the tangent of 135? Negative 1. So I'm going to plug negative 1 in here. So I'm going to have tan x minus 1 over 1 minus tan x times negative 1, which is tan x minus 1 over 1 plus tan x, which is what we wanted. I haven't decided yet. I got to talk to Mr. Shadowell.
Yeah, oh, shit. I could put in a word.
You need to know these for calculus, so it's even though I know you'll probably forget them if I make you memorize them, you know. So ready?
We did 3C.
All right, 3C. Now, as I write it down, just to save space, because I never have enough room, I am changing, again, this, you've asked me to use a problem, so I am changing my tangents and cotangents into sine over cosine and cosine over sine. That is my very first step. Now, I'm doing that for a couple of reasons. First of all, I almost always do that, just do it. But also, I noticed that what I want to end up with is all sines and cosines. So I'm just going to get rid of the things that I don't want to end up with. Now, I'm glad we're doing this one because I think we talked about this before. I know I did with some people. This fraction is separate from this fraction. I do not have to do the same thing to both fractions. I am going to look at this complex fraction and I'm going to multiply everything by cosine. Perfectly legit. Top and bottom by cosine. That's that fraction. This one, I'm going to multiply top and bottom by sine. Because that will get rid of the little denominator in each of the two big fractions. So what am I going to be left with? Cosine squared over cosine minus sine, because these cancel, that's why I did it, plus sine squared over sine minus cosine. Now at first I was starting to get excited, my heart was like beating faster because I saw this, but then I noticed what? They don't match. The denominators don't match. Now they're really close to matching, but what's the difference between them? How do I make them match? What do I need to do? I got to take out a negative or put a negative in, whichever you want to do. So if I'll just leave this the same, so cosine squared over cosine minus sine. And then I can multiply top and bottom of this one by -1, and won't that make this denominator then cosine minus sine? And it turns this into a minus then. Just got a common denominator. If I multiply this by -1, it turns it around. So now I'm not quite as excited because I don't have, this is not 1, but But what is kind of cool about it, my numerator,
Cosine squared minus sine squared.
yeah, and what about that? Is the difference of squares. And what do I do with the difference of squares? Yep, so it's cosine plus sine and cosine minus sine over cosine minus sine. Now, remember, because of the pluses and minuses, there is no canceling that you can do at this point. But here there is, because you're allowed to cancel entire parentheses. You can't cancel pieces of it, but you can cancel the whole chunk. If they want. And what am I left with then? All right.
Which one was that?
3C. All right, so who sees something else on the paper? Okay, I'm happy to keep doing identities, but please understand that's only a part of the test.
5B.
Well, wait, at first I'm doing 3B and then I'll do what you say 5C. And the thing about these identities is you're not gonna have any of these on the test. So the idea is you need to practice them yourselves. Because none of these exact ones are on here. Okay, 3B. Well, there's a couple of things. I don't really care which side you work on. This side kind of intrigues me because don't I have a formula for the cosine of x over 2? My formula for the cosine of x over 2 is this, but it's squared. So basically I just have 1 plus cosine x over 2, right? Well, okay, this is what I want to end up with. So if I multiplied everything here by secant, and again, that's kind of a random thing, but it's what I want to have in my denominator as a secant. So if I multiply by secant, what am I going to have on the top? Secant plus, what happens when you multiply these two? 1, the reciprocals, over 2 secant, which is what we wanted. So, it's easy enough, David?
Does it say that it's secant x and then cos x together is 1 on the sheet, or are we supposed to just know that?
How are you supposed to know
No, I
that?
just said, are we supposed to know?
They're reciprocal, so you're supposed to know secant is 1 over cosine. So when you multiply 1 over cosine times cosine, you're gonna get 1, right? Anytime you multiply reciprocals, you get 1. Okay, what was it, 5C I'm doing next?
5B.
5B,
I have a question on this one. How do you get the square root at the beginning?
it's the formula, the cosine of x over 2.
Oh, I see.
Or you said B? All right, so this is an equation that I am solving in radians. Well, the big issue is you have a 2x on this side and an x on this side. The quiz question that we went over a little bit ago, the only thing we had was a 2x. That's okay. You can do a problem in 2 x's, but you can't do a problem in 2 x's and x's. So something's gonna have to be changed. And since we have a formula for this, I would suggest we change that, cosine 2x, right? Now, this is one of those wild ones. We actually have 3 versions of that formula. seeing that this is a cosine in the problem already, if this were a 0, it wouldn't matter to me. But since that's a cosine, I think it's probably smartest to use this version of the formula. Do you understand what I'm saying? You can use one of the other ones, but then you're going to have to change the signs anyway. The signs are going to have to be changed into cosines. So it's just as easy to jump in and use that formula. All right, now what? Now at least it's all x's, cosine x's. So that's good. What do I do now? Set it equal to 0. See that right there? What kind of an equation is this? Quadratic. And quadratic equations get set equal to 0. And when I do that, I'm going to move that cosine right over here in the middle. So my problem's kind of in the right order. Now what do you want to do with it? Yeah. What do we do with quadratic equations? We factor them or we use the quadratic formula. I think this one factors. So 2 cosine and cosine. And plus 1 minus 1. I think you're right. Let me do a quick double check there. Yep, you're right. So that means that cosine is negative 1/2, or cosine is 1. Okay, well, where is the cosine negative? Cosine is negative. Negative. That would be 2 and 3, wouldn't it? Cosine is x. X is negative. What kind of an angle is right there? We've already seen one today. That angle is 60 or pi over 3. So what are the answers to this piece of the problem? X either equals, please don't say pi over 3. It would be that angle, which is pi minus pi over 3, or 2 pi over 3. Or it would be this angle, which is pi plus, or 4 pi over 3, right? Now what about a 1 here? What do I do with that? Yeah, you can't draw a triangle, because if you try to draw a triangle, can adjacent and hypotenuse match? No, that makes sense. So I'm going to have to look at my circle, and where around the circle, the unit circle, where is cosine 1? 0, right here. Right here. So the answer to that one is 0. So there are your 3 answers to the problem. Alana?
Can we do 12F?
12F. Find the radian measure of the largest angle of the triangle whose sides are 8, 9, and 10. Alright, so we got a triangle, and the sides are 8, 9, and 10. And our job is to find the largest angle. Well, which one's the largest? The one at the top, right? So I'm finding that angle. Now, the fact that it's in radian measure, that doesn't mean anything except my calculator needs to be set in radian mode. That has nothing to do with how I do the problem. It's just the mode that my calculator is in. So, how am I going to find an angle of this triangle? Law of cosine. Boys and girls, if to find an angle of a triangle, unless it's right triangles you can do different things with, but if it's a regular old random triangle, to find an angle or a side, it's the law of sines or cosines. That's it. That's all you need. So looking at this, Does everyone understand why sines isn't gonna work? The law of sines isn't gonna work? So, 10 squared equals 8 squared plus 9 squared minus 2, 8, 9 cosine x. Is that okay with everyone? Now, we gotta be in radian mode just because that's what the problem says. There's nothing special about it. That's just what it says. So let's see if we can type this in correctly. Anybody come up with anything?
1.25.
I got 1.25 also. Now it tickles me when I'm up here typing and you guys are just sitting there watching me press buttons. I don't want to brag, but I'm probably going to do okay on this test. You guys are the ones that need to practice. Type it with me. Okay? All right, that's it. Now, I am set in radian mode, so I'm going to go ahead and change that before I forget, because I think most of the rest of them are in degrees. All right, what else do you see on here? Oh, I see one we better talk about. Let's look at 6A. What's different about 6A? It's an inequality. Whoa! We've never done an inequality. Right? So we're going to do it today. And you have done, I want you to think about it for a second. I was just think for a second. When you solve problems like this, and you solve problems like this, was the solution of the the actual working of the problem anything different? No. What was different was that this one was like a dot on the number line, and this one you had to do some shading on the number line. That was the difference. So that's all that's going to be the difference here. You're going to go ahead and solve this as though it were an equals. So I'm going to divide by 2 and pretend this is an equals. So where is the cosine 1/2? Now I'm in radians. Where is the cosine 1/2? Well, either in quadrant 1 or 4, right? And for the third time today, our angle is pi over 3. So where does the cosine equal 1/2? Well, it equals 1/2 at pi over 3 or at 5 pi over 3. So if this were an equals, we're all set, right? Everybody's good with that? Okay. So now, instead of drawing a number line, you're going to draw your cosine curve. So just draw your cosine curve, and you remember what that looks like. At least you better remember what it looks like. And it's from 0 to 2 pi, just like the direction said, and just like we always do. Now, would you agree that pi over 3 is like right here? So I'm going to put a open dot right there on my cosine curve at pi over 3. And then I'm going to come over here and I'm going to put another open dot at 5 pi over 3. Now remember, I want the cosine to be 1/2. So doesn't it make sense that that is where the cosine is 1/2? But the problem says I don't want it to actually equal 1/2. I want it to be less than 1/2. So where is the cosine curve less than 1/2. Isn't that all of this right here? So the answer isn't just pi over 3 and 5 pi over 3. The answer is everything in between them. So the interval from pi over 3 to 5 pi over 3. Now, notice I'm using parentheses and open dots because that is a less than and not an or equal to. That would fill in the dots and make brackets. Oh, that wasn't so hard. There's one more. Let's try it. Huh?
Can you just see that?
Whatever you want to do. I wouldn't, I draw it, but that's up to you. Okay, let's try the next one. Oh my gosh, I don't believe that we're gonna get a 60-degree angle again. That's okay. All right, let's solve it. So let's see. Will this say sine x is greater than or equal to negative root 3 over 2? Okay. Where is the sign negative? Here or here? Root 3 over 2, that's my pi over 3 again. So what are the angles that have a sign that actually equals negative root 3 over 2? One of them would be 4 pi over 3, and the other one would be 5 pi over 3. Okay, is everybody with me to that point? So 4 pi over 3 is right here, and 5 pi over 3 is right here. Remember, you're getting a value of negative root 3 over 2, so that's going to be down here. This point blocking in, and this point blocking in. That's where the sign is negative root 3 over 2. Now, where is the sign bigger than that? Well, it would be all of this, right? And this. So what is my answer? Everything is blue. So it'll be from 0 to 4 pi over 3. And I'm using a bracket because that's a colored dot. Or from 5 pi over 3 to 2 pi. And I'm parenthesing 2 pi because my directions were parentheses at 2 pi. Okay? So a little new, but you got it. You got it under control. All right. What do you think? See another one?
We do number 9.
9. Find the area of it. Yeah, we did one kind of like this the other day.
Yeah.
What was our strategy with finding the area of some random weird shape like this?
Splitting it into 2 triangles.
Yep, we're going to split it into 2 triangles. And we actually can split it however we want. But I think when we did it the other day, we decided that this might be the easiest split because that's a right triangle. So triangle 1, triangle 2, the area of triangle 1 is 1/2 6 times 9, base and height, right here, perpendicular, base and height. So that's what, 27? Okay, that's easy. Now, what are we gonna do with triangle 2? Okay, so we can find that dashed line I drew in, right? And that'll be easy. You could use the law of cosines if you wanted, but it'd be easier just to use the Pythagorean theorem, since it's a right angle. So let's see, that's 36 and 81, 117, square root of 117. And now things are looking good because I've got two sides. What do I need to find the area of a triangle? I need two sides and the angle between them. Okay, we kind of went about this kind of back door last time. Do you remember what we did? Alana?
If you find the angle of the triangle 1,
Yep.
and then,
We'll call this angle right here X. And we can find it with the law of sines, but it'd be easier just to say tangent X equals 9/6. And then second tangent that. You could absolutely use the law of sines if you wanted to. Actually, you could use the law of cosines if you wanted to. But this is just the easiest. And what is that? Make sure you change back to degrees. Second tangent. Did you get 56.31? Which makes that one, is that 118? 118 minus that, which is 61.69. Are you still here? So the area of triangle 2 is going to be 1/2 square root of 117 times 16 times the sine of the angle I just found. So 1/2 times the square root of 117 times the square root, times 16, regular 16, times the sine of second answer. I got 76.18. Is that right?
yeah.
So then I'll add that to my 27, and the total area is 103.18. And you want to put a unit on that if there is one, there isn't. So if it were inches, it'd be square inches, square miles, whatever it was. Okay?
Thank you.
Well, you're very welcome. Another one. Let's go. Right?
Just a question on that one. If you give us one on the test that doesn't have a unit, do you want to just put like unit squared?
That'd be perfect. Sometimes I'm a little lax on that. Alana?
Can you do number 8? Please.
Okay. This test, like all your tests, is part calculator, part not. So the ones that have stars by them are the calculator problems. So we've got a regular octagon. What's octagon mean? 8 sides inscribed in a circle. So here's my octagon, it's described in a circle. And the radius of the circle is 9. So basically, Your Honor, my strategy is the same as it was here. I've got a weird shape, don't know how to find the area of it, so I'm gonna break it up into triangles. The easiest triangles to split this up into, there would be different triangles I could do it, but the easiest is just to come out from the center so that I have 8 congruent triangles. Not only that, but I already know my 2 sides. I'm looking at this triangle right here. I already know my 2 sides. The only thing that's missing is what? If I had that angle, I'd be home free. Do I have it? Yes, I do. Because there are 8 of them, all in a circle, which means each one has to be 360 divided by 8, which I think is 45. So the area of the triangle is 1/2 9 sine 45. But then the area of the octagon will be 8 of those. So that's it. That's it. So I got 229.10. And I think I did put a unit on that maybe. I did. Inches squared, square inches. Alright, that's enough for now. Here is your assignment for the next time we have class. I want you